Okali dokali. It should be starting. Woo! So that's not what I wanted at all. Oh yeah. I put that on there just in case and I forgot to remove it. Thank you. Okay, all I did while it was crashing was start setting up this special expect clause which can transform the tokens for me. If we're already at a greater than sign, we don't do anything. If we're not at a token that can become a greater than sign, we just expect error that it was expected and return. Now we're going to do the transformation on the token to replace the current token and eventually return a new token if we need it. We want to say in all cases where we don't have the token kind we expect, that's unreachable. That's might even just want to say this is where I'd kind of want to ice, honestly. So doing this expression doesn't work because there's no compound expressions in C#. So there's also not no return functions either. So instead, token kind, new token kind, switch current token kind, default, then context diag ice, and throw new unreachable. I wish I had no return function so I don't have to throw unreachable everywhere. The ice we care about is boom. Okay, so then case greater. Let's do not this. Do this. And actually, I guess I should just do the first one and then copy everything. So greater equal is going to say the token kind is whatever kind equal. Just straight up equal break, right? Greater equal, greater equal. Okay, so then this is greater equal greater. Okay, so then we have greater. I'll just fucking do it this way, this is fine. Greater. Typing greater kind of sucks. Greater equal. Okay, so 1, 2, 3, 4, 5. So that's 1, 2, 3, 4, 5. Cool. So then what we want to do is say var new token location is new location at current token or current location even offset +1 current location length -1 current location file ID. Then var new token is going to be new syntax token. And it's going to be the new token kind. What else does, what order is it? Location first, location is second, new token location. So then, LCA is actually broken on my machine. Well, I don't know what that means. You're gonna have to elaborate. So then current token should be tokens. I've copied all the tokens out of the module, which is actually kind of interesting. Because module tokens is, this will have to be okay. Tokens sub position is going to be new token. Straight up. That's just going to have to work. And then we don't return an error. We just also don't advance. So then I should probably say out syntax token greater, the actual token that we care about, out token greater, like that, which I mean, yeah, but I'm only returning if it returns true. So let's say token greater equals current token, and then not this. So then in this case, we want to construct a missing token. I don't have something to construct a missing token for me, do I? I just have to kind of fucking do it. So token greater then becomes token missing, like that. Then we error. Then we can say token greater is new syntax token kind greater, new location. So that's current location offset 1 source file ID, like that. Which I can actually put all the way the fuck up here so that it's very the first thing we do. Create a new greater token, put it at the current location, then transform this token, and then we're good. So then here, this import query named is expecting a query name ref. Okay, so that's actually a good call. Query name ref, parsing an import query. When we're parsing an import query, I think I do actually want to have a second version of parse name ref, which is private syntax node parse name ref no template arguments, which might just have to be, no, because I want the return type to be different. So what we're actually doing is this, and then just returning the name ref like this with new no template arguments like that. So what I think I want to do is have this available so that this can use it. Like that. Then out var token greater so that I have it. Then this thing just kind of exists. So what I want to do is private, so names is an array of syntax token. So private syntax token parse name ref impl, which can then have out name ref kind. Then all of this junk return names to array, because names is an I-read-only list. So then we get the parse name ref impl. So then var names is parse name ref impl out var kind. And then this is length. Like that, which I guess really doesn't matter. So then the same thing here, everything for names becomes this. So then our actual name ref becomes this. Here we have template arguments we can check for. So then in parse primary expression here, parsing with the template argument check. So this has no template arguments. That uses the impl, that uses the impl. This can check for template arguments because it's in type. Parse type, that's fine. And this can check because it's an expression. Okay. So we have decided on this and this. How badly does this blow up if I come back over to test.ly with my this thing? Does it blow up at all? Does it work? Need to return a default syntax node where no expression was parsable. Okay, so at token kind comma. That's got to be here then. Right? Oh. So then if try consume, try advance, token comma out. If we did hit a comma, then we do this. That's what we forgot there. So it's trying. Okay, no errors. Our other declarations look good. This one, decal binding, is a name ref for vec with template arguments 2 and f32. The identifier is v, the token semicolon is there. So if I put spaces everywhere, that should not affect the parse at all. That should still be a template. Cool. This is starting to work. So then I should also still be able to do arbitrary sub-expressions like 2 times 4, which should then have 2 times 4. Beautiful. Still templated. And we can say instead maybe 2 is greater than 4 to make sure that that check works and doesn't close the template argument list. 2 is greater than 4. Beautiful. Then for shits and giggles, we're also going to be looking for, let's say the double greater. It should error on a greater than token. We have a lot of work to do, syntax expert binary. Yep. So what that's telling me is diag note. We have parsed an expression, and it couldn't be a declaration, and it couldn't be a type. So we didn't know what to do with it. Technically now, this is parsing like this. It's vec2 whatever is greater than v, which really it can't be a statement expression on its own. So we'll need a way to report that, which we can probably do in Sema instead of syntax maybe, but it's syntactically usually knowable. So I could have another flag for could be expression statement, and yeah, but this is parsing actually correctly. So that's cool. Hey, I don't know if it's going to work for everything, but Sarade, your idea is working. Cool. So let me just go ahead and mark that as that, and then we can stress test template arguments, which is not done. So that's cool. Name ref is otherwise technically done. So let's put stress test template arguments just as its own thing to happen eventually. So that's one thing done. We've done it. So then git add status first. Make sure I didn't add anything stupid. That's fine. Git add dot git commit. Update how template argument parsing works. Git push. All right. So that's cool. That is cool. So the next thing is, can it parse a function declaration called v? Expected a type. Ooh. Decal function. I mean, that worked, though. Where did it expect a type, and why don't I have a location? What the heck? So that's a string we have built. Oh boy. Type. Okay. Parse delimited something. So this is happening in parse function decal starting at name. Oh, because I need to be able to check. So function parameter should only be called if we're not at a closing parenthesis. So parse delimited. If at closers, it's not allowing 0 of a thing. So really what I want is, if we're already at the closers, return an empty list. That should give us no parameters. So this needs to be at current location. That's our problem. Okay, so now we've got decal function named v, which is whatever, and it returns this stuff. So there's our function declaration. Now, if Sarade is still here, did we have an idea on how the hell we're gonna parse functions in this case? Because this is the easy case. The hard case is bar baz here. So let me get the case that works. I have this one working. I'm going to make it the only case we have for right now. Bar baz, bar baz, bar baz, bar baz. Decal function, blah, 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 blah. Compound. We're declaring a function that returns a pointer to bar. And it's called baz. It has no parameters. There's no parentheses in there for right now. What's going to happen is if I say I32A, I32B, that's going to complain. We have a lot of work to do and whatever. So the binary it's parsed is bar times baz, and we're at this open paren because it doesn't know what the fuck to do. So parse binary expression. In parse binary, we're checking if we're allowed to have declarations, and are we in a position where a declaration could happen? So that means, are we at a star or an ampersand or an identifier? Rather, is the operator that we're on either a star or an ampersand for a pointer to or a reference to type? And are we at an identifier? So the next question I'm also going to have to do here is, are we at an operator and not at the keyword mute before I even get here? Just in case that matters, and not at, but not peak at, because that's going to break. So I think what I really want, I'll tell you what I want, is I want to do this same check while we're at an operator with precedence and we don't see if the current and peak at 1 mute. No, that shouldn't happen, right? I actually made that so that shouldn't happen in any case where it matters. So this is fine. I think it's fine at least. We'll double check. So if we're at a thing that could start a declaration that isn't already otherwise obviously a declaration. So that's star or ampersand, followed by an identifier, followed by equal or semicolon means it's a binding declaration, so that's good. If it's an open parentheses, we have some work to do. The easiest trivial case is if the next thing is a closing parenthesis or a semicolon, or and followed by a semicolon or an open brace or an equal greater. If that's the case, right, these are the three cases, right? If it's a semicolon, the one that's hard we'll leave down here, I32A, I32B, right? So we have that, we have this, which has something in it, which we don't actually parse yet, or we have this. So these will work. But these last two won't. So these are the successful two. I haven't parsed this one, but it should work. It's checking for the same thing. So we now want this. The next thing I can do is we have some work to do. So if peak at is closed paren, that's a thing. If peak at 2, or rather if peak 2 kind, definitely a pipe start, then we're also going to do the same thing. So then if it's something like, instead of I32, which isn't actually lexing properly, if it's like int, this should parse as int a as a token, as a parameter. So then I get decal function, blah, 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 compound, decal function, a pointer to bar, the identifier is the name of the function. The parameter is a built-in int named a. Boom. Okay, so the only case left now, I'm going to say this is foo, this is bar. The only case left now is baz. So. What we're looking at here, we need to then, we're at an open paren. We're at an identifier and an open paren. What we're going to do then is say, try advance, identify, outvar ident. Which isn't even a try, it's a consume. We're going to call it a consume. Ident, token, ident. Then we're going to consume token kind open paren, outvar token open paren. Boom. Easy enough, easy enough. The next thing we need to do is parse any expression. Var, maybe first param or arg. First param or arg is going to be parse expression. This is default. If first param or arg, context-sensitive languages are just so much harder to parse, it's genuinely crazy. It is, but I am gonna solve the problem anyway. If the first param or arg can be a type, and we are at an identifier, then this should be a parameter declaration. Then we are going to hand this off to like parse function decal. So we have a function decal starting at name. We're now going to need a variation of this function called starting within parameters. So we don't need the name, the open paren, or the so what we're going to do here is save. We need the return type. We need syntax token name, and we need syntax node first parameter type. First param type. We'll do that. So then this is what I'm going to call from here. This. So we need to pass it the expression. The return type is still this. Return type. Then we have token ident. Then we have first param or arg, like that. We want to return this. So then we have consume identifier out var token first param name. Right. So then we can say var first param is new syntax parameter, which needs first param type token first param name. So then I can say var parameters, which can be a syntax decal param array, param decals. If consume token comma, then param decals is going to be first param expand this remaining params, like that. Oh, because it's returning some actual shit. Parse delimited is returning a read-only list of syntax node. Parse function parameter. First off, why is this mad? Oh, probably because I'm in the middle of editing something. This should only ever return this. Else. That's why that's mad. Okay. Otherwise, param decals is just going to be first param. Then we're here. I'm going to change that up here as well. Okay. So, does baz a parse? Did I do it? Decal function, foo_bar takes a baz a. Oh my god. Oh my god. That might have worked. So, the only thing left here is if it can be a type. So something I'm going to have to do here is say syntax node RHS. And I think the easiest thing I can do is say else RHS is this. So then RHS has not been assigned in all cases because now I need to say RHS here is just not a thing that happens. So notably, this is the only place I'm consuming anything. And we're not returning here. I really want to use a goto here. I think what I'm going to do instead is just say, if RHS is null, parse it. Then this can become null. So then what I want to do here is, instead, RHS is going to be parse expert call from first argument. So we're going to want this to be creating a node type. We don't want to create a node type from the operator. What we want to do is parse from a call, which is the thing that we're looking at here. We have LHS star, we have consumed our identifier. So the arg, the thing we want to do is call the identifier. So we want to say var call target is syntax name ref create from just token ident. We've already skipped the open parentheses. So we have call target, which I'm just going to call syntax callee instead. And then we want the first argument to be first param or arg. Okay, so then this if just becomes, oh, that's not what I wanted. Sure, becomes this. So then I need to parse call from first arg, which I'm going to put right above continue. What the heck? Where am I? Private syntax node is not that, this. So I need syntax node callee, syntax node first arg. So we're going to do a very similar thing to what we did with the function declaration. So syntax node array args if try advance token kind comma, then args is going to equal to first arg expand remaining args. So then var remaining args is going to be parse delimited of parse expression comma delimited and expression. Closers would then be close paren. We'll also look for a token kind semicolon and maybe a few others. Oh, because the parser requires token kind dot default. That's why. Not token kind default. Parse context dot default, like that. Else args is just first arg. Then we want to expect token kind close paren, return new syntax expert call, which I don't have yet, which needs callee and args. Right? So let's go into syntax expressions. Let's do it above types. So right here, sure. Syntax expert. Yeah, we'll put it below here actually. Syntax expert call callee. So then callee a call expression cannot be a type, then I need like that. So then I have expert call. So a way we can test this, I don't have a way to put an expression anywhere, but we can see what happens if I say var foo bar I. This should throw an error with syntax expert binary, which should be foo on the left and bar I on the right. I believe that means this is working. Let me go double check in my parse binary if it can be a type and we're at an identifier. That should be all I need to check. I think we've done it. I think we've done it. I think we've done it. So I'm going to git status, make sure I haven't changed anything I didn't want to, git add git commit. Let's try to be a little professional here. There. And as always, if you want to take a look at this, it is up on GitHub, nashiora.com, or not, github.com/nashiora/choir. It's in the description. At least my GitHub is. You'll find it. Okay. Is the comment in line 892 still valid? 892. Yes, because we're creating the call expression. Otherwise, we give up. It's an invocation of the right-hand side. So we're constructing the right-hand side, which is call, which is an invocation. That's what like a call. All of the previous things were attempts to make this a declaration, and then we give up trying to make a declaration and turn it back into an expression. I don't comment often, but this is kind of a strange thing to put into a binary parser, so we're walking through each step, trying to articulate in order what we're looking for, and this is we're done checking for a declaration. We're going to continue parsing as a binary expression with the right-hand side. And it's a little bit far removed, being 2 nested scopes in, so I just wanted to make sure it was labeled as such. Okay. That took a lot of my stamina. I've been streaming hour and a half, not including the downtime. Do I want to do a handful more expressions? We're past all of the things I thought would be difficult, assuming that the new things we add don't break them. I don't have a dedicated test runner set up yet, and I don't want to do that on this stream, but if I would have encountered this problem, I would have just given up. I have been trying to solve this problem for years. This is my latest attempt to solve the problem. And Serrated Eternal Boy over here had some good ideas that we workshopped a little bit for my specific use case in the Discord. And it looks like, for the most part, they're working. The other thing I had is I was going through Roslyn, the C# compiler, and they solve this problem differently with what they call a scanner inside the parser, which their scanner just marks the current state of the parser and reads tokens without constructing syntax nodes until they can determine definitively one way or another what something should be. And then it rewinds the parse state and commits to parsing based on that result. That was going to be the alternative, but that's a lot of work for how complicated the types are. If types could only ever be types, that would be fine, but types can contain expressions, which makes things significantly more difficult, so I wanted to find a way around that. So right now we can do one more declaration, and we can try, for example, : vec of 1 let's do 1 plus 1 times 2, which is a vec4 of f32. That's a kind of complicated type that we're going to turn into a declaration. We're going to make it a pointer. And that'll be fun. It's something I want to test. Pointer should just work. That's why C# doesn't have preprocessed macros, I guess. I don't know what you mean by that. Because macros usually just expand into tokens, and then you scan ahead with the tokens. But I guess if what you mean is unexpanded, it'll always expand to the same thing. By the time you get to parsing, the tokens are going to exist. Bar here. We want... let's try a different variation of this called X or L or A or something. So this can be 3 minus 1 times 2, I don't fucking know, minus 1 again. Just something different. These should be declarations as well. It's complicated as hell, but can the parser handle it being a declaration? Need to return a default syntax node when no expression is parsable at token kind star. Interesting. I think I know why here. Hold on. Here's another thing I want to check on then. Let's go into the primary expression continue. We're parsing a star or an ampersand followed by a mute, which goes to parse type continuation. We should also check star or ampersand when peak at star or token kind ampersand. That should also happen. We're still at star. It's still not happy with star. Let me report where that is in parse somewhere. Let me just actually look for need to return default syntax node. So we're going to ice on current location. So I know exactly which token it's complaining about. It's complaining about 323, which I assume is this, 323. So I think what needs to happen here, something. I wish I could run this through the debugger. But I can't right now. So I need to know exactly what the call stack is to get here. We're getting there though, which is good. So what we're looking at is we're going to attempt to parse an expression, I believe. And if we do, this becomes an expression. Don't you have an exponentiation operator, or am I tripping? Yes, but it's a caret. A caret. 1 to the power of 2. So RAID has double star for exponentiation. So when I parse an expression or a type, and then I hit continue, if it's a star or an ampersand, and then we hit a star or an ampersand, then we want to parse type continuation. So I think what I've forgotten to do here is parse type. No, I did it. Oh, but it's just literally not in here. Okay. I don't have the ability to parse a pointer type. Well, that would be the problem. Okay, so then fucking case token kind star advance and type node is new syntax type pointer. That would do it. And that's type node. Use break. And then ampersand is reference. There we go. That's a big one. But now we have, in our compound expression, we have a function declaration which is called bar, taking a parameter just called fucking, oh, because it has to be a type, so it's just already decided that's the case, I guess. No? How did we get to a function declaration with a missing name? Expected an identifier. I mean, you're right. Oh, because it hits... This is on the left. There's no valid operator on the right, so it just falls back to the declaration parser in the first place. Let me go check that that's the case. This parser's getting big. Parse syntax and statement context. So it does this. Then if it can be a type and the right isn't an identifier, so that's what we're hitting. This is a single expression that can be a type, because it is a type. And then it sees this. So it's parsing a declaration, it's saying I is the value, there's nothing there, okay. So, we have a new problem. If Serade is here, I can say it out loud, and I'm going to say it out loud anyway, but this, I don't know if this is going to be an issue, but the dereference operator, or the reference operator, I guess, might cause issues. I'll have to get other ways of parsing expressions in here. In this case, it's okay that this is parsed as a declaration. And I think if I said var foo equals whatever this is, that it would still be okay, potentially, because this is nonsense. But if I have star bar is what I looked at, that would be a dereference of whatever's returned by bar. So I'm thinking, is there anything on the left that might eat up star because it thinks it's a type? I don't think so. I think I might be fine, but this is something to keep on radar. So I've pinged you in there just to follow up if I do, I guess. Maybe now that I've talked through it, it's not going to be a problem. Yeah, let's just, for example, if I do this, and if I just say star bar, this should ice and tell me I have a dereference expression. Except no, because I haven't implemented it yet. It's just at star. I think it'll be fine. So what we're looking at here is that's definitely a type because it's a pointer. So I can say i32i and get a valid parse tree. So it should be a pointer. Yep. I should be able to continue with even more pointers into oblivion and still get a declaration. Pointer. I should also be able to say, if I do just the reference, it should work. No errors. We end up with a decal function. Let's see. Type reference, that's what I was looking for. Okay. If I do reference pointer, it should be a pointer to a reference. A pointer to a reference. Cool. I think we're good. I think we've done all the complicated work we can. So I'll start with a few. I'll start with a few expressions probably, and then call it before 3 p.m. my time. The next half an hour. That'll be my goal. Okay, okie dokie, okie dokie. What is my friend saying? Hold on. That's maybe. One of my friends is giving me some color palette ideas to revive my more complicated version of the textbook. So maybe we'll stream some of that soon too. Okay, I want to parse a few things. I think the first thing we should do is just if we are at, if try advance token semicolon out var token semicolon, then no matter what, we're going to return new syntax, come on, new syntax stmtxpr of syntax, and it's going to be a statement expression. And we can include the semicolon because we have it. Easy. So let's go to syntax statements. There's a compound. I'm going to say syntax stmtxpr. So that just needs syntax node expr syntax token expert location children is come on. Okay. Syntax token semicolon. I didn't pick the right ones. There we go. So then we have a statement expression. So now we can start at least parsing some normal ass expressions in here. So if I said foo, well, why am I at 2? I don't want 2 spaces, I want 4 spaces. Thank you. If I just say foo, this will be a statement expression. It's not a good statement expression, but it is. The next thing I can do is else if try. We need is assignment operator basically. So if current token con is lie assignment operator. I don't even need the lie prefix. Is assignment operator. The terminology is kind of arbitrary. I'm saying syntax statement means this is a statement, and then the following thing is what it is. So this is a statement, which is an expression, because I want it to be a statement. I don't actually have inheritance in the syntax tree telling me what is what, so I'm using the naming convention to do that. So if I go back to expressions, anything that is definitely expression, like expression binary, is syntax expression binary. Anything that is definitely a type is syntax type pointer. So anything that is definitely a statement, syntax statement expression. So while in the vernacular I would call it an expression statement, in the type name, I'm not doing that. So do I give a shit about making this a syntactic error? If I come into syntactic scopes, we can then say in statements, I'm going to say errors associated with each of these. Because I need to know, if we're doing an assignment, it has to be a valid L value, which is more a thing for Sema to determine, really. Syntactically, only so many things can be, but we might just want to handle it semantically instead. I'm not sure. The same thing could be said for the expression statement. I think we might want to handle that syntactically, but we might not want to. Let's go to token kind and say, before I forget actually, we have a fuck ton of operators we have to think about. So, for example, equal and bang equal great. Percent colon needs to go with, we need to have like a whole ass fucking this thing here. So we have star, that's fine. But then we have slash colon and percent colon. I got a text. Texts are usually important. Let me check that before I forget. It's not important. Okay, so slash colon and percent colon. Both of those are good. Then minus minus is different. Minus percent. So or plus pipe minus pipe or plus percent minus percent. Then colon greater equal or less colon and less equal colon. Then done greater, less. Question. I don't know the precedence of this. Hold on, let me go. They put it below these other things. They say that question's down here. Which I think makes sense. Okay. And then caret. I didn't do caret anywhere, but caret probably goes with star. Caret being, I mean, it's going to be higher than star because it's exponentiation. So, this shouldn't be 40. This should be 50, and this should be 60. Oh, that's a good point. I think the best way to make the caret right associative is just to not do that. If I come over here to the parser, and we parse expression, so here I'm parsing a binary expression. What I might do is var binary is this. Then if try advance, fucking token caret out token caret, then return new syntax binary of binary parse expert parse fault. It probably should, but let me make that a to-do for now because I don't have that implemented. Token caret. I don't do a whole lot of right associative operators. Okay, let's take a look at the binary expression handler. So we're talking here. And actually, I believe we might have to change that. Hold on, let me go double check my previous parser. Not this one, that's colors. This one. We might have to check if precedence is correct here then, because I'm already doing greater equal. Sure, what does source do for binary? Oh, well, binary doesn't exist here, Sheree. Damn. Well, useless. For the time being, this is okay. I don't have any other right associative operators that I'm parsing in the big operator parse loop. Because assignment, while right associative, is a statement, so I don't parse it in the expression parser. So if caret's the only right associative operator, I'm not going to do it right now, because I'm getting ready to leave in 10 minutes. Or less. I might even just call it here before I get too far ahead on my whatever I'm doing here. We did this. We're going to have to do assignment operators, and that's going to take not a long time, but just enough time to set up the actual assignment operator handling. So I'll probably start there next stream, maybe. We've done this. Have I done anything else? I've done a grouped expression, I think. We've done statement. We did expression, if all else fails. Which really is just expression statement. If there's a semicolon, that's it. What I should do then is instead just say expect semicolon, outvar token semicolon, and then it really is if all else fails, and then I've got this if that I have to implement next, and then I don't have to diag ice on anything anymore. If question needs to be right associative, you're probably right. Then we'll mark that to be done as well. So let's public static bool is right associative binary operator. So that needs this token, whatever, and it needs to switch. On default, it's false. On question, or caret, it's true. Then there. So then back in the binary parse loop. So somewhere in here. So this should be greater. By default. So let's say our current precedence is here. We also need our associativity. So let's say right associative is this. Can you just, is that what I'm looking for? So then, while we're here, we will is token operator right sock is token operator dot associativity dot kind associativity. And I'll put this way down here. There. So problem is here. Do I just say false? Because we have no idea what we're at yet. We're not at any token. So if I just come over here and I said a plus b times c, we'll start with that and see what it parses as, because I have no idea. I have actually no idea what it's going to look like. So expression binary is on the left has a plus on the right bc with higher precedence. So that's fine. If I do a plus b plus c times d times e plus f, does this look like what I think it should look like? This should be a plus b, that's fine, plus c times d times e. This is on the right hand side of plus, that's fine. C times d, then times e, then plus. I think it parsed the right hand side of I plus b times c as a declaration, or maybe I misread that. Binary. Oh, did it? It shouldn't have, because we weren't in a plus b times c. This one? Oh. So what I need to do then is that. Good catch. Much better. A plus b times c. Okay. So then a plus b plus c times d times e plus f. That looks at least not incorrect. Right, I guess what I'm really curious about is a plus b plus c plus d. I would assume the ordering doesn't really matter, because it doesn't. So it's a plus b evaluated first, then plus c, then plus d, which is fine, right? Nothing wrong with that. So now if I did a caret, if I can find the right goddamn key, this should be a caret bcd. So a caret, which it's not. So either caret didn't get marked as the correct precedence, also, hold on. do I need... Do I need that? I don't think I do. But I might, because it should never actually get to that point where that's necessary. But I might. I think I got this from a different parser, and I think I implemented it wrong in the last version of LIA. So we might have to... Hi, hello, Mr. Mulamy. This doesn't work. You're back home. Stockholm. Compiler doing actually pretty good. I can briefly show what we got working. The VOD will show the process much better, but we have worked a lot on making sure template arguments and declarations parse correctly with the shitty syntax I have. So we can do complicated shit like, let me just go back actually, all the way the hell back to some of the complicated shitty stuff that we have parsed. Like that. Let me do, just take that out actually. We'll try all of these should just, oh that's why I did it. Give me my 4 spaces back. Try to parse that. Ideally, that's no errors. No errors. We've got all these complicated declarations in a context where expressions can happen, and we have a compound expression with a statement that is a, oh, right, this is the one that parsed, this is the one that failed to parse for some reason. This might be the one I need to fix. The next one is a declaration though, and the next one is a declaration. So these two parse perfectly fine as declarations. This one's kind of got a problem that I need to fix. I forget exactly why it has a problem that I need to fix, so we're going to have to take a look at what it parsed. So it parsed star times call bar. There's no template arguments. I should probably go new this, and both places that I have this need to be null, actually. That's one thing that's wrong, but the rest... Do you remember why we skipped over fixing this? I don't remember why we didn't fix this if it happened. I have no idea either. So, I mean, the vec part is correct. Nameref vec 112f32. That's all of the template arguments. So then we hit star. This should be a pointer type, but it's not. We hit the case in parse binary. I'm gonna have to go to my to-do as well and just say because that's not working correctly. Why is this wrong? So we decided if it can be a type and we're at an identifier. So it parsed for first param or arg, it parsed nameref bar. No, we want the binary on the right, which is wrong. That's vec less than. Right, so it started at vec, and it got less. Maybe this was working, and then my precedence parser broke it. Hold on. Let me go back to whatever the hell I was doing a second ago without right associativity. Because maybe it was working. Right, because if I just say this, we don't give a shit about associativity anymore. Now it's a decal function. Now it's correct. So it was working. And my associativity check broken. Am I right? So I'm going to leave this as is for now. We're going to have to fix associativity. What did we even fucking do? Good enough. That'll at least remind me. But I'm about ready to go. Top of the hour, like I said. Glad you're back, Mugame. Sorry you got here right at the end. But we've got all of the funky declaration stuff parsing mostly figured out, save for some bugs with operators just not working correctly. And I think what I might do to fix the precedence issue is just not even consider precedence here at all. Just if we hit a right associative operator, call parse expression again. That's not correct, technically, so I won't actually do that. If it's in the big operator parse loop, then it's wrong. If I pull it out of the big operator parse loop, then it's technically correct, kind of, but also still not. I'll have to check my implementation of this, because this being in here, I think, is the problem. We'll figure it out on one of the next streams. We've done more than I wanted to, though, so that's good. Thanks for stopping by. Go join ye old Discord server over here in the description, where I'm going to keep talking about this shit. Hopefully I don't fix this off stream, but I might, because I've got a busy weekend. I might not stream until a few more days. So keep updates in the development channel if you want to see what's going on. And I'm going to go relax. Goodbye.